Hi, so we're still going to look at trigs and we're going to look at the identities today. So basically this is a unit circle is what we're going to be looking at. And if, for example, we were looking at, and I'm going to write SOHCAHTOA up here again. So we're looking at a right angled triangle, which could be part of a unit circle, which I'll come to in a minute. This is the line X, this is Y, so this is the point XY up here. If we wanted to find the sine of theta in that angle, it would be opposite, which is this length here, which is the Y thing, over the hypotenuse, which is 1. So this value for Y actually is 1, sine theta. And in the same way, cos of that angle is adjacent, which is the X, over 1. So this is cos theta. And strangely enough, tan equals sine over the opposite over adjacent, which is sine over cos. And also the gradient of the line is the difference in y over the difference in x. Hence that's the same. So what happens is in your book they use a thing called the unit circle. And it basically moves, the angle moves anti-clockwise round in a circle, and you can obviously get the angles off of it. So cos is 1, because that would be the length, because remember we said the radius of the circle was going to be 1 from this, if this is 1 moving all the way around. My x value would be 1, my y value is 0, and the tangent would be 0, because the gradient of the line is 0. And as you move round, these things happen, so you also think you've got positive values, and you can get these values because that's obviously a vertical. So this is something that is called the unit circle, and the values that you get obviously are quite tricky at times, but I don't actually like using it. So the idea is, if you were to plot the unit circle for a sine graph, for example, it would start at 0, at 90 degrees it would have a value of 1, 180 degrees it would still have a value of 0, and at 271, and then 360, 0. So you end up actually with a graph like this. I find it's much easier to draw that graph and draw on relative values when I want to find the values, and then know, obviously, if there are two values that give you the same answer. You can get this from the sketch quite quickly. There are ways that you can, take on rules where you add or subtract. So for a tan, it repeats every 180, so you can subtract 180 from this one or add it on if you want to go up. For the sine, the same thing. You can subtract 180 from that one, and the cos, you have to do it in 360s. So these are important, but it's much easier, I think, to actually draw the graph. So from the information we've just learnt, we know that with this we have got this is sine theta, this is cos theta, and that means tan theta is sine over cos, and from Pythagoras we get our equation sine squared plus cos squared equals 1 from here. Those are your two identities that you will have this year. Nothing else comes in. Okay, so these are the important ones. So this is the type of thing we have, proofs. Here are your two equations, the only two you know at the moment. So what happens is you start, and we always say if it's a proof you're going to have 3 lines there. So it's not an equation, you're not trying to solve theta, you're trying to prove that this side, the left hand side, which is LHS, equals the right hand side. So we just start with one side and we do the one thing that we can do, and in this case the first thing we can do is change the tan to sine over cos, because there are no tans on this side. In fact, there are no sines on this side. So you start with the side that looks the messiest and try and make it the easiest. Usually it's the left hand side, I don't know why. So here we go. So that's it. Sine over cos is changed to tan, and do it very simply. Don't try and change anything else at the same time, because you may make a mistake. And also they like to see that you know, because that equation, these two equations aren't given to you. So if you use them, you get a mark. So there's a mark there. Then you simplify whatever you've got. So now we've got sine squared cos over cos. Then you would divide by cos, top and bottom, leaving you that, which you can either change the sine squared to say sine squared is 1 minus cos squared, or you can recognise that that cos squared is 1 minus sine squared, And you say, okay, well that's cos squared, which is the right hand side, and that's the whole proof done, which is great, obviously. So let's have a go now with me. Oh, there's my pen. Doing some of this. So as long as my pen's working, something's come up that I don't want there. Right, so I think I've got a red pen. Let's go with the blue one. Right, okay. So we go, again, it's an inequality, so we're going to do left hand side equals. And we're going to sines and causes over here, and there are no tans. So the first thing I'm going to do is change all the tans to sine theta over cos theta. And then usually I put my equals straight underneath that line. So then also 1 over a fraction inverts it. So I'm going to write it out again without stupid 2 fractions. Oh, wrong. Right, so one thing is good here already is that we've now just got everything in terms of sine and cos. The next thing I need to do, because that's just one fraction, I've got 2 here, I think I'm going to create a common denominator where I've got cos theta and sine theta on the bottom, which means I've times all of this by sine theta, which gives me sine squared theta on the top, and all of that by cos theta, so I end up with cos squared theta on the top. And from our beautiful equation, the ones that we know that sine squared plus cos squared equals 1, which equals this. And I'll just rearrange it so that it looks like the one on the top. If they're timesing, it doesn't matter, and that equals the right hand side. Okay, that's all you need. Now this says simplify, so again we're not going to do anything special with it. It just says simplify. So I've got, and it says look out for this. So you can see, so it's kind of looking out for this. So simplify. So I'm going to take 5 out because there's 5 in both of that, which will leave me with sine squared theta. And we know that 1 minus sine squared theta is actually cos squared theta. So that's literally all we've got to do for that one. So it's part of this that makes this easier is playing. Just playing with what you're supposed to be doing. This is a proof, so I'm going to have my left hand side. Do try this first, pause this and have a go. So I've got my 2 equations, my tan and my cos. This ends up as 1. Because these are causes, I'm going to see if I can do something here. I don't know if it'll help or not. Haven't done this one before, we'll find out. So I've got, actually, I might change this one at the bottom first because I think this might make it a bit easier. So I've got tan x, cos x, all over the square root of, now 1 minus cos squared x is actually sine squared x. Okay, I'm going to go again. I've got tan x, cos x, and I now know it's over sine x. Now, this is interesting. I've got tan x, and then I've got cos over sine x, which from the one previously we know is the same as 1 over tan x. Now, you could do it like that, or I might take it back, and then you would just cancel and get 1, so that's fine. You could say, all right, I'm going to get, oh dear, what happened there? Cos. I'm going to change my tan to sine over cos. So if I do sine x over cos x for my tan, and I also know I've got cos x over sine x here, all multiplied together, then I divide by that, and I end up with 1, which is my right hand side. Which might be easier than seeing that that is the inverse of tan x, but you will get there at some point next year. Okay, and then on this side, again, it's a proof, so I'm going to start with my left-hand side because my right-hand side looks much nicer. And this one, you have to recognise that that is a difference of squares. So I know it's n to the power 4, so it must be cos squared theta plus sine squared theta. And it must be cos squared theta plus sine squared theta, because that actually ended up as a... So I've got a minus and a plus for my difference of squares, and I've got it over cos squared theta. So that's a good start. But I also know that cos squared theta plus sine squared theta is 1. So I'm only left with cos squared theta minus sine squared theta all over cos squared theta. And because I've got two terms up there, I'm now going to separate out my two terms. So where I had a common denominator, I'm going to go back to what I had before. It's funny when it doesn't print it out. So that then becomes 1 minus tan squared theta, and that equals the right hand side. So that's pretty good. Okay. Have a go at another one, just to make sure. I haven't got much more time, but we'll give this a shot. Prove that tan squared theta is equivalent to that. Now, I might this time start with the right hand side, because I've only got one term on this side and I'm not really sure what to do. And that makes it a little bit tricky, but you could do it the other way around. So, other way around as well. So I've got 1 over cos squared theta. Because it's going into one term, I kind of want cos squared theta as a common denominator. So I'm going to change my 1 to cos squared theta over cos squared theta. So I've got, oh, this is going to work, 1 over cos squared theta, make that my common denominator. And then we know that sine squared is 1 minus cos squared theta, so that works. And we know then that that is tan squared theta. Oh, left hand side. Okay, if I started then with my left hand side, I would say, okay, so I've got sine squared theta over cos squared theta. And then, because I've only got cos left on that side, I might want to say, okay, well that equals 1 over cos squared theta. So literally I'm doing the reverse. So I've got 1 over cos squared theta minus cos squared theta over cos squared theta. Gives me 1 over cos squared theta minus 1. So it doesn't really matter, it's whatever you feel comfortable with. And if you get halfway down one side and can't see where you're going, try going down the other side and see if you get to the right answer. It's worth a try. So these exercises then are on 10C and well worth playing with. Some lovely proofs. Proofs are lovely once you get used to them, and they are quite similar. The more confident you get with them, the better you'll be. Well worth taking the time. Good luck, and give me a bell or an email, text if you need some help on these. Well done.